Next up, standard to vertex form. This is where it gets tricky. Now standard form, right, Miguel? Ax squared plus bx plus c equals 0, or like whatever, right? And the other would be ax minus h squared plus k equals 0. Or y, or this could be y or f of x or whatever, right? Okay, so we're going to do, there's two cases. There's an easy case, and that's when a is 1. When a is equal to 1, it's easy. When a is not equal to 1, it's difficult. So we're going to do both right now. Ready? We're going to do both of them. Here's how you spell that. Both of them. We're going to do both of them. The easy one, we're going to do the easy one first, and that's when a equals 0. So let's do this one right here. Let's say f of x equals x squared plus 6x minus 5. And let's say the instructions said change to vertex form. Actually, the really tricky thing that Cambridge tests like to do, Michelle, is they won't even tell you that it's changed to vertex form. They'll actually put a letter here, and they'll write it what it's equal to in vertex form, and they'll put some other letters, and you have to figure out what the letters equal. It's really weird. I can't even explain it any better. I have to show you. Okay, so first thing you're going to do, it's like you use completing the square, okay? But you're not moving anything to the other side of the equal sign. But you do use completing the square. So first thing you're going to do is, rewrite it and just leave a space. No equals, no nothing. Just rewrite it and leave a space. That's the first step. Okay? Good? Now the second step, we're going to make this thing right here a perfect square so we can factor it. Because you see how like it's a perfect square right here in vertex form? We have to change that into a perfect square. So to change that to a perfect square, you take half of 6 and you square it. And you add that right here. Half of 6 is 3, right? And since we have to factor next, we don't actually square it. We just write it like that.
What are we making?
Wait, what now?
What are we making a perfect square?
This part. X squared plus 6x plus something, so that it's a perfect square, so it'll look like that. Hold on, just a second. All right, now here's the hard part. I added 9, right?
Oh, yeah.
Now this is not the same as that anymore because I added 9 to it. Do you understand what I mean, George?
Yeah.
So what can I do? Like I don't want to add 9 to the other side because I want everything on the right side. So what can I do so that it's still equal to what it was before? Subtract 9. So over here, you subtract it. Over here you add it, and over there you subtract it. Just let me finish the whole thing, and then I'll get to your questions. Just let me do the whole thing, and we'll get questions. Okay? So we took half of this, squared it, and added it, and subtracted it from the same side. So if I give you $9, take away $9, you still have the same amount of money. You're still broke.
So it's the half of b squared?
Half of b squared. Hold your questions till we're done. We're almost done, actually. So the next thing you're going to do is you're going to factor this. X squared plus 6x plus 9, which is x plus 3 squared. Because that 3 goes right there every single time. And then minus 14, correct? Is minus 5, minus 9, 14, negative 14. So there's vertex form. These two are equal. This is vertex form. Do you see?
So half of b squared.
Half of b squared.
To
You add it and you subtract it.
Oh, you added some empty space?
That's why you left that empty space in there. Okay, 1 second. Lauren, you had a question first? I can't hear you. I really can't hear you. You're getting quieter.
Okay, when you rewrite it to move -5,
Yeah. All I did is write it in left space, that's all. I didn't do anything mathematically. I just physically made more space in the middle so I could add something in there. Yeah, yes ma'am. You factored it. X squared plus 6x plus 9 is equal to x plus 3 squared. Yeah? Yeah. Yes, Lauren? It is completing the square. It is exactly completing the square. Yeah, we're not moving the 5 to the other side. That's true, but we are still completing the square. Yeah. All right, so we're good? Okay, that's the easy one. And it was pretty easy, right? Yeah. Okay, now the difficult one. Face melter time. Okay, you ready? We have to change that into vertex form. So the first thing you do is you don't write math with a pen.
Wait, aren't our Cambridge exams don't we have to write inside?
Partly, yeah.
That's so messed up.
Kind of looks like an eye with a eyebrow.
Yeah, it does. Yeah, I wrote plus and I had to scratch it out because it's supposed to be a minus. Okay, so first thing you do, you just write yourself, you write the equation again and you just leave space. You didn't change anything, you just left some physical space right there because you're going to put some stuff right there. Right?
So just leave space.
Leave space, that's it. That's it. Now, bless you. You're going to take, like, A is going to be 3, correct? So the thing that's weird about this is you have to take 3 out of both of these numbers. You have to factor out the 3. So this is where it gets a little tricky. But you're already used to that because when we solved by completing the square, that's how I had you do it.
Yeah.
Right? So it's like this. Okay? Good so far? Because, and here's why. If you multiplied 3 times this, you would get 5 back. Like if you multiplied 3 times 5/3, you get 5.
So you factor A.
Yeah, so you divide 3, you divide A out of both terms. Yes, sir.
Did you put equal in the one?
I hate my life.
I was going to ask you, Mr. Waller.
Man. All right. All right. I think I need a cookie. So, yeah, I have cookies.
You didn't give one to me. You missed my jello.
Oh, he's going to eat it in front of us. He is. Look at him.
Oh, no.
Yeah, I have cookies.
How can you do this? No.
So these have chocolate chips, and then all that stuff is like shaved chocolate.
It looks so good.
Those are really good. This is good, right, Sam? Mm-hmm. What a really good cookie. Man, I need some milk. I need a glass of milk, Katie.
Some milk.
That's good. Wow. All right. Sorry. That's delicious. Okay. Hard part. Hard part. You know why I ate the cookie? Number 1, because it was good. Number 2, because I got your attention now, and this is the hard part. You've just been tricked, and I got a cookie for tricking you. Shut up, Isaac. All right. You know how you have to take half of this number, right? And it's negative 5/3. So you have to take half of negative 5/3 and you have to square it. And you add that right here. Okay? So negative 5/6. And we do not square it in here because our next step is we're going to factor, and that's the factor you're looking for every single time. Miguel, you're writing this down, right? You have a weird way of writing stuff down sometimes. Yes?
Don't you have to have like the square root of -5/6 to
Hold on. Yes, so we're not done yet. We're not done yet. So Gabe's objection was, like last time we added it here and we also had to subtract it over there, which is correct. However, do you see how this is inside this parentheses? And what's the 3 doing to it? So there are actually 3 of these we're adding. Do you see that? There are 3 of these we're adding. There are 3 of these. Because it's 3 times. So there are 3 negative 5, 6 squared being added. Do you see that? There are 3 of them. So we have to subtract 3 of them. Where we added 3 of them, there's 3 of them right here. So we have to subtract 3 of them. So we have to subtract 3 of them. Now I'm going to go ahead and square it here. Okay? See, look, here's the thing, Manny. It's 3 times this.
Oh, so there's 3 of those.
There's 3 of these
Okay.
that I added.
And you squared it.
And I squared it over here because no sense not to.
Alright.
Yes, ma'am.
What is it, plus negative 5 over 3 or over 6?
Over 6 because it's 1/2 times 5 over 3. Okay? What's your next step?
Adding the
Factor, right. You're going to factor here, and you're right, you're going to add there. Both at the, you can do both at the same time. So next thing you're going to do is you're going to factor here and you're going to add there. But here's what I want you to do before that. I want you to make sure you know why there's a 3 right here. Why is there a 3 right there?
There's 3 negative 5.
Because there's 3 right here. You added 3 of these. So you have to subtract 3 of them. Otherwise, it's not equal. That's the trick right there. That's the hard part. It's really not that hard. You just have to pay attention. Be careful. If you don't understand why that 3 is there, like right now, you need to ask. Yes, ma'am.
So you square it and then just put the 3 in front of it.
Uh-huh.
But if, say, that number was like a whole number,
Yeah.
would you multiply it by 3?
Uh-huh.
and
Yeah.
subtract it?
We're still going to multiply by 3. We're going to reduce it and stuff. Yes, ma'am.
The next step is to factor and add it.
Yeah, so we're going to factor these. We're going to factor. And we're going to add these.
Oh.
Yeah. So, yes, Lauren? Oh, sorry, I just saw the hand. Yes, Leslie.
So what if it was a negative 3? Would you add it to the other 3?
Yeah. So you would do minus negative 3, which would be plus. You're right. That's a good question. She was asking, if you don't understand what she meant. She meant like, what if A was negative? Then this would end up becoming minus negative, which would be positive. Yeah. All right. Danielle, are you texting me? That's creepy. Oh, well, I didn't know. It looked weird. Okay. Hold on. Let's finish this, and then we'll get to questions at the end. Okay. So put your hand down. Your sabaka stinks. All right. Let's see. That's 12, right? No. Yeah, that's 12, right? 3 reduces with 36 12 times. Is that true? So what I really have is I have 1 minus 25 over 12. Is that true? Yeah, yeah or no? Yeah. And I have to get a common denominator, so I have to multiply this by 12 over 12. Is that right? Yeah? Okay. So that'd be 12 over 12. So then, finishing it up, 3 x minus 5 over 6 a square minus, is that 37 over 12? That's ugly.
When back to the brown part, the reason that the 3 like that's being like grouped is like didn't get rid of it is because you didn't do it to the negative 1.
Right. We're not solving, right? And here's the trick. Here's the thing. Vertex form is a times x minus h squared plus k. A has to be 3. A has to be 3. If I did something to divide this 3 away, then it's no longer 3, and it wouldn't be equal to it. Yes, sir.
Why
Why is x minus 5 6 squared right here? Because when you factor this right here, it's a perfect square. We completed the square. We made it a perfect square, and that's the number right there you're looking for every single time. Like, yeah, you remember? Like, we squared these earlier and saw that it would equal that? Yes, ma'am.
When you added, or I don't know, 12 over 12 minus 25 over 12.
Okay.
Is that in green?
Oh, right here. Yeah, I've got a common denominator.
Why?
Well, because I could have just written it negative. No, I didn't want to do that. Just because you have to add 1 to this, so you have to get a common denominator.
Why do you need to add 1?
Because it's negative, because you have to combine like terms over here.
Oh!
Yeah.
Okay.
Yes, ma'am.
How did we get 25 over 12?
How did we get 25 over 12? Oh, because it was 3 times 25 over 36. And you reduce.
Oh.
It's 3 over 1. Yeah. Yeah. Yes, Lauren.
What can we simplify the fraction? Because it can be 36 and 3 and
Yeah, you could write it as a mixed number. It doesn't matter. You could write negative, negative 3 and 1/12.
on tests, will they prefer to write it?
It doesn't matter.
8 equals 1. We go, like, you know how it has the 3
Yeah.
for A? Do we put a 1 for A?
No, you don't have to. So if A is 1, you don't need to write 1. You can just leave it blank because it's an implied 1. It's like 1 times something. Yeah. Gabe, what's your question, Gabe? Okay, practice time. You ready? Oh, what's your question?
How would you graph that?
How would you graph it? Well, your vertex would be 5/6 positive and negative 3 and 1/12. So that would be your vertex. And then your y-intercept is negative 1. You could do the math if you wanted. I would use this if I had it. And then, is it going to have x-intercepts? Is it going to have x-intercepts? I see people saying yes and no at the same time, which means you guys are confused. How would you know if it has x-intercepts? Okay, so George said it depends on which quadrant this vertex is in and then the direction. Which quadrant is this in?
Oh, the third.
Fourth quadrant, right. Fourth quadrant. You guys are silly. That's a fourth quadrant because remember the vertex is the opposite of that.
Oh, yeah.
Right? That's the fourth quadrant. And what's the direction? It's up. So it's going to be somewhere over here. It's going to look like that. Oh. So it will have 2 x-intercepts. So, well, you would solve this. You would set it equal to 0. Add that number to both sides. Divide by 3. Square it. Square root it. And then add 5/6. It would just be loads of fun. It would be almost as fun as eating one of those cookies.
Are we, can we just go to do that?
You could do that right now. It's no big deal. Yes, Daniel.
Where did you get the denominator as 12?
This 12?
Yeah.
Because this was 3 times 25 over 36. And you have to reduce. 3 goes into 36 12 times.
Oh.
Okay, practice time.